Welcome. In this video, we are going to take a look at electrical energy density. All right, so electrical energy density is electrical energy divided by volume. So let's write that down. So electrical energy density this equals electrical energy divided by volume. We can use the variable U sub E for electrical energy density. Now we can find the relation between electrical energy and electric field using the energy of a capacitor. And so the energy of a capacitor is equal to 1/2 CV squared. C is the capacitance, V is the voltage across the plates. And we know the capacitance for a parallel plate capacitor is C is equal to kappa, the dielectric constant, times epsilon zero, the permittivity, times the area of a plate divided by the distance between the plates. And then the voltage across the plates, V is equal to E times D. Okay, so we can make these substitutions and find energy is 1/2. For capacitance, we'll use kappa, the dielectric constant, times permittivity times A divided by D. For the voltage across the plates, we will use E times D, and that quantity is squared. So let's expand. We get 1/2 kappa epsilon 0 A divided by D. We've got an E squared and a D squared. And now we can cancel the D, and we have 1/2 kappa epsilon 0. We're canceling the D, so we'll move it up next to A. So we end up with an A times a D, and then times E squared. And now an A times a D is equal to volume. So we can divide both sides by the A times D, call that a volume, and we have energy divided by the volume, and what's left is 1/2 kappa epsilon 0 E squared. And so what we can say is U sub E is 1/2 kappa epsilon 0 E squared. And that is the value at an instant in time. I hope you found this helpful. Thank you for watching. I'll see you in the next one.